Hello, and thank you for tuning into Team 2007's Electrical and Computer Engineering Senior Design Project Demonstration video. The focus of our project is autonomous package delivery drone technology. Why? Well, in short, package delivery drones are expected to be a significant contributor to the unmanned aerial systems markets, which are projected to reach $4.8 billion by just 2021. Furthermore, with commercial giants such as Amazon, Google, and FedEx already investing heavily into these technologies, we can expect package delivery drones to become increasingly relevant in the years to come. The objective of our project is twofold. One, to build a fully functional remote-controlled drone to serve as a base to build upon further. And two, to modify this drone with features that would assist in package delivery, such as the ability to identify objects, or packages, and to autonomously navigate to these identified objects. A pictorial representation of our objective can be seen on the current slide. Although relatively simple in theory, realizing such an objective is actually quite complex. For this reason, we broke our project into 4 phases to make our design efforts more tractable. Phase 1 encompassed building the remote-controlled drone that will later be modified with additional features. Phase 2 considered the computer vision system that would be used to identify objects and how to interface with this system. Phase 3 integrated the computer vision system with the drone and provided a way to locate recognized objects in relation to the drone. Finally, Phase 4 ties everything together by providing the previously calculated object position as a waypoint for the autopilot, resulting in automatic navigation.
For phase one, we needed to do extensive research on the parts that we needed to build the drone, as well as ensuring that each of the parts are compatible with each other and making sure that we do not exceed our budget constraint. Once we received the parts we ordered, we were able to build our drone, but we still needed to design a mount for our Pixie Cam and a part to hold our battery. We used the Yukon Maker Studio to 3D print these parts. This is what our completed drone looks like. After we finished building our drone, we then began to program our Pixhawk 4 flight controller. This flight controller handles various input and output parameters. We opted to use Q Ground Controller as our flight control software to fine-tune these parameters. These parameters include but are not limited to roll, pitch, and yaw values. We also use this flight control software for setting up the radio transmitter and receiver telemetries, as well as calibrating the battery and electronic speed controllers.
In phase 2, I was tasked with teaching the Pixie 2 to identify and recognize object. The Piximon is the software that runs on Pixie 2 and allows it to recognize and train objects by assigning each object a signature label. And as the Piximon is running, it will output some important object data, such as position, size, XY screen coordinates, dimensions, and when that data is outputted, that data gets sent over through a communication interface, either I2C, SPI, UART, or USB. Originally, our group wanted the Pixie 2 to recognize barcodes. However, we realized that barcodes are not very unique by color, and because of light and shadow in the background, it's very difficult to tune Piximon to actually see the barcodes. And with that complication, it's also hard to find a clear detection rate. Therefore, our group decided to abandon that idea, and we went to stick to single colored objects, particularly strong darker colors, because they require less tuning. And through some experience, our group was able to achieve a detection range of between 10 to 14 feet, as you'll see in the next few slides. In one of the experiments, we had one group member standing between 5 to 14 feet from the camera, holding an orange notebook. Another one, we also had the same group member holding a red shoe cover, also within 5 to 14 feet.
In Phase 3, we integrated the camera and drone position estimation data together to predict where a recognized object is in relation to the drone. We did this by extending the PX4 flight control software to interface with the Pixie 2 camera and extract position information about recognized objects. This position information is then transformed into 3D coordinates that can be used by the autopilot. The image on the left shows the Pixie 2 camera mounted to the drone and connected to the flight controller's external SPI interface. The image on the right shows some output data from our custom PX4 driver and coordinate transformer. In Phase 4, we would have updated the autopilot software to accept inputs from the coordinate transformer. In addition, we would add in another flight mode that would trigger navigation to the recognized object. However, due to the disruptions caused by the currently ongoing coronavirus pandemic, we were unable to complete this task. However, this would make an excellent starting point for future senior design work. Overall, we have completed the first 2 design phases and are finishing up the final touches on the third. As mentioned earlier, we were unable to complete Phase 4 due to the coronavirus pandemic. but it is our hope that our contributions are expanded upon in future design projects. Thanks for watching.